So here is question number 21, everyone. Two particles are moving towards each other due to mutual interaction. Their de Broglie wavelength are 4 lambda and 9 lambda. The ratio of their respective de Broglie wavelength in the frame of center of mass. Now, suppose this is particle 1, this is particle 2. Here is their center of mass C. Now, since they are moving with mutual force of attraction, means internal forces, net external force is 0. So, center of mass, if it was initially at rest, then it will remain at rest. Means the momentum, total momentum of particle from the center of mass frame will be what? 0. If it has P1, it has P2, then what will happen? P1 plus P2 will be 0. Now, we can write that magnitude of P1 therefore will be equal to magnitude of P2. Means they are equal in magnitude, suppose P. Now, since they have equal momentum in magnitude from the frame of center of mass, so therefore we know very well P is inversely proportional to 1 by lambda, or lambda will be inversely proportional to 1 by P. So what will happen? Lambda 1 upon lambda 2 will be what? P1 upon P2, which is equal to 1:1. Therefore, we can go with fourth option, which is absolutely correct. Now move on to the next, that is 22 number. So here is question number 22, everyone. A neutron with an energy of 5 mega electron volt collides elastically with proton and is retarded. Assuming that upon each collision, the neutron is deflected by 45 degree, the number of collision which will reduce its energy to 4.88 kilo electron volt is about what? We have to take mass of neutron and proton equal. Suppose this is the neutron, here is the proton. Neutron has kinetic energy initial K, suppose, and proton we can take it at rest. Now it is colliding with this proton. After collision, like after first collision, taking is at x-axis and this as y-axis, what is happening here? The neutron is deflected by 45 degree. Proton will go, suppose, in this direction, making an angle theta. Neutron has, suppose, kinetic energy K1 after collision and proton has K2 after the collision. Now momentum will be conserved. So applying the conservation momentum in x direction once and then in y direction. Along y, what we are going to get? See, initial momentum along y was 0. Final momentum along y is under root 2mk1. This is momentum. Kinetic energy is given, then momentum will be under root 2mk. Sine 45 minus under root 2mk2 sine theta. Or we can write under root 2mk1 sine 45 equals under root 2mk2 sine theta. Equation number 1. Now again writing the equation along x direction. Initial momentum along x will be what? Neutron momentum, that is under root 2mk, where m is the mass of neutron, which is equal to mass of proton according to the question, equals under root, after momentum, 2mk1 cos 45 plus under root 2mk2 cos theta, taking it as equation number 2. Now squaring and adding 1 and 2. Squaring and adding 1 and 2. On the left hand side, we will get under root of 2mk1 sine 45 whole square plus under root 2mk minus under root 2mk1 cos 45 whole square equals 2mk2. Now solving it gets us k2 equals k1 upon 2 plus k plus k1 upon 2 minus 2 under root k into k1 multiplied by 1 upon root 2. One more step, k2 will be equal to k1 plus k minus 2k k1 within root. Now since the collision is elastic, therefore kinetic energy will be constant. Initial kinetic energy k, taking it as equation number 3, initial kinetic energy k will be equal to final, that is k1 plus k2. From here we can write k2 as k minus k1, equation number 4. From 3 and 4 we are having k minus k1, that is the value of k2 equals k1 plus k minus under root 2k k1. Now after solving this we will get the relation between k1 and k, that is k1 equal to k by 2, means the kinetic energy of neutron after one collision is become half. So after each collision it will become half, and after n collisions, the kinetic energy of neutron will be, suppose kn given by initial, that is k 1 by 2 to the power n, where n is number of collisions. Now after n collision the energy is given, that is 4.88 kilo electron volt. Initial is 5 mega electron volt, or you can write 5000 kilo electron volt multiplied by 1 by 2 to the power n. Now by the property base is same, power will be equated, we can calculate this value of n, and this comes 10. So therefore total number of collision will be what? 10, and we can go through option number 3, which is absolutely correct. Now move on to the next, that is 23 number. So here is question number 23, everyone. Select the incorrect statement. So you have to read the question first of all properly. We have to pick up the incorrect statement, not correct. Option number 1. Electric line of force may form closed loop. Generally we know electric field lines start from positive charge and terminates to negative charge, and these are the conservative electric fields. But induced electric field, they can form closed loops. It means they may form closed loops, they may not form closed loop. Option number 1 is true, but we have to pick incorrect one. Let's talk about second option. Magnetic lines of force may not form closed loop. We know very well, whether it is induced or whether it is normal magnetic field, they always form closed loop. Since magnetic field lines always form closed loop, so therefore it is incorrect, and we have to pick the incorrect one. So we will go with second option. Let's talk about third and fourth option as well. Third one, an accelerated charge is the source of electromagnetic wave. Absolutely true, an accelerated charge can produce the electromagnetic wave, but we have to pick incorrect one, so we will not go with it. Fourth one, magnetic field can be produced by both conduction current and displacement current. This is also absolutely true, but we have to go with incorrect one, so we will not go with it. So 1, 3 and 4 is correct, so we will not go with them, but second is incorrect and we have to pick up the incorrect one, so we will go with option number 2 finally. Now move on to the next, that is 24 number. So here is question number 24, everyone. The dimension of half epsilon naught E square C is same as that of, where epsilon naught is permittivity of free space, E electric field, and C is the speed of light. We know very well the energy density U is given as half epsilon naught E square. Energy density, which is energy upon volume. Therefore, the dimension formula of this particular expression can be written as dimension formula of energy upon dimension formula of volume multiplied by dimension formula of c, that is speed of light. Energy ml square t minus 2, volume L cube, and speed, that is speed of light, Lt minus 1. After solving it, we will get the value, that is Mt minus 3, which is the dimension formula of intensity. And hence, therefore, option number 3 we can go with, which is absolutely correct. Now move on to the next, that is 25 number. So here is question number 25, everyone. 4 identical polarites are placed coaxially with 45-degree angular separation from the adjacent one, as shown in figure. The intensity I of light emerging out of 4th polarite will be what? Where I naught is intensity of unpolarized light. Now we know very well the intensity of light just after passing through first polarite becomes half. So if I naught is passing, we will get I naught by 2 here. And according to law of Malus, if angle between them is theta, then the intensity I will be given as I dash cos square theta. So intensity right here, what we will get? I1, which is I naught by 2 into cos square 45 degree, which is I naught upon 4. Now intensity right here, that is I2 we can get. I2 will be I1 times cos square 45 degree, that is I naught by 4 into 1 by 2, I naught by 8. Now intensity right here is suppose I3. So I3 we will get what? I2 is entering I2 cos square 45 degree, that is I naught by 8 multiplied by 1 by 2, and ultimately the result is I naught by 16. So therefore option number 3 we can go with, which is absolutely correct. Option number 3. Now move on to the next, that is 26 number.